Today we're going to be working on your quiz review for your quiz, which is on Thursday. So yay, I know everyone's so excited. And you can use this as well for your test, which is the 9th. Okay, so let's get started. We're going to start off here with some proportions. Remember, we just cross multiply like this. So we end up with 9a plus 9 equals 10a. We subtract 9a from both sides. We end up with 9 equals a. Over here, same thing, cross multiplying. 7d minus 28 equals 3d. We end up with 4d equals 28. Just move that over and that over. d equals 7. And over here, we're going to cross multiply again. We end up with 12x squared minus 30x plus 42. I'm going to write the rest over here. Minus 30x plus 90. Okay. And we are able to get rid of those 30x's from both sides, right? Okay, which we did. And now we subtract 42 from 90, so we have 48 equals 12x squared. 48 divided by 12 is 4, so 4 equals x squared, which gives us that x equals plus or minus 2. Okay? All right, let's look at number 4. The area of a rectangle, so let's draw a rectangle, where area equals 162 square inches. The ratio of the width to the length is 3 to 6. Find the length, okay? So, let's use our dummy variable, say m. You know I like to use m. All right, so 3m, 6m. Remember, this side here is also going to be 3m. And this side is also going to be 6m, okay? But we're multiplying these out, okay? So this times this needs to equal 162. So we have, hold on. Okay, so we have 3 times 6, which is, so we have 18m squared equals 162. 162 divided by 18 is 9, so m squared equals 9. So m equals plus or minus 3. Obviously, it has to be plus, right? Because you can't have a negative length or width or something. So the length, 6m, is going to be 18. And the width, 3m, is going to be 9. All right, and if you calculate it, 18 times 9 is going to give you 162. All right, so let's move on here. Okay. The perimeter of a triangle, the perimeter is this side plus this side plus this side. So the perimeter is 44 centimeters. And the extended ratio, remember an extended ratio is a more than 2-part ratio in this point. In this problem, it's a 3-point ratio. So of the side length is 542. What is the length of each side? Let's use a dummy variable t since it's a triangle. So, and it doesn't matter which side you mark it, I'm just drawing it. So we have 5t, 4t, and 2t, right? So we end up with 5t plus 4t plus 2t equals 44. That's 11t equals 44. So t equals 4. All right, we're still not done. So now we need to find the length of each side. So you plug in for t. We end up with 20, 16, and 8. Okay, those are our side lengths. So the following is the extended ratio that compares the lengths of the sides of the triangle. Find the, what does that say? Find the length of each side. Messing up over here. Okay, sorry guys. This all goes to this. Okay, the following is extended ratio. Find the length of each side. Okay. So if DE is 4 times something, you would divide 16 by 4. So our dummy variable, let's just say x, equals 4, right? Because this is 16, and DE, the ratio is 4, so you did 16 divided by 4, which gives us 4. EF is 5, so you would do 5 times 4, so y equals 20. All right, and finally we have y plus 4, which y is 20, so we have 24. Now we need to check to see if that checks out. This divided by 4 is 4, this divided by 4 is 5, and this divided by 4 is 6. So that works. Okay? All right. The following is the extended ratio that compares the lengths of the sides of the triangle. Oh, we just did that one. I'm sorry. Let me go down even more. Okay. Name a postulate or theorem that can be used to prove the triangle similar. If they are not similar, just write not similar. If they are similar, complete a similarity statement. So already looking at this, I know these two angles are congruent because these are vertical angles. We're already told that these two are congruent, so this one has AA similarity, right? Angle-angle similarity, because if these two angles have congruencies here, this angle has to be congruent to this angle, okay? Which makes these two triangles similar. So in our similarity statement, it's very similar to how we would write a congruent statement. Triangle ABC is similar to triangle EDC. Okay? Now let's look over here. Once again, we're going to have an AA postulate because this angle is congruent to this one, this is congruent to this, and this is congruent to this. So once again, we have triangle ABC is similar to triangle DEF. Okay? Let's look at number 9. So we need to check to see if these are in the same ratio as these. So is 6 over 9 equal to 8 over 12? That is our question, okay? So we can go ahead and simplify this, right? So we have 2 over 3 equals both of these, so both of these divided by 3, and both of these divide by 4. We have 2, 3, check. This angle is the same, so we end up with the side, angle, side postulate, okay? See, side, angle, side. Side, angle, side. And they have the correct scale factor, which is 2/3. So this triangle similarity statement, triangle ABC, is similar to triangle DFE. All right, number 10. So we're told right off the bat, because of these arrows, that these lines are parallel, right? So, if we look at this as a transversal, so if this was a transversal, here, hold on, this angle would be congruent to this angle because they're alternate interior angles. And this angle would be congruent to this angle, right? So we have our two triangles. This is one triangle right here. And another one would be, our bigger one, is this triangle right here. Okay? So you can see the two triangles. Because these are vertical angles, this is also going to be like that. And this is going to be congruent to this angle. So this is the angle-angle. This is the angle-angle postulate. So, I'm sorry, I'm going to have to erase what I wrote. So finish marking it if you can. In order to do a similarity statement, I can't see a thing that I did. So sorry about that. So we end up with triangle. TYZ, I'm going to do the big one first, you can do whatever. TYZ is similar to triangle. Oh, hold on. Yeah, I think it was, yeah, okay. Triangle TSR. Okay? So there we go. 11, if these are vertical angles, so this is 46 degrees. Right off the bat, we know that. These lines are parallel, right? So we can extend them. This angle and this angle are alternate interior angles, so this is also 53 degrees. So by the angle-angle postulate, triangle ENG is similar to triangle BNA. Okay? So finally, number 12. We have to check that these are in the same ratio. So we want to do 2.5 over 4. You can do 4 over 2.5, whatever, equals 5 over 8. And we need to check to make sure this is correct. We don't want to deal with a decimal here, so another way to write this would be 5 over 8 equals 5 over 8. Check. So this is the side, side, side postulate. Well, actually, we have to check if this is 5, 8, 5 eighths. We need to check this as well. So we end up with 3.75 over 6 equals 5 over 8. Hold on. 3.75 times 3.75. Okay, 3.75 times 4, we end up with 15 over 24. Multiply this, both the top and the bottom, by 3 is equal to 15 over 24. So this is checked, so it's the side, side, side postulate. And I'm going to write it up here. Triangle ABC is similar to triangle JKL. Alright, so that's the answers to these. Okay. Oh, that's a little too tall for me. Alright. The side length of triangle ABC, so triangle ABC, B, C are 2, 5, and 6. And triangle DEF, has side lengths 12, 30, and 36. You want to write it in these in the same order that you wrote these. So if I switch the 5 and 6 here, if this is 5 and this is 6, this would have to be 30 and this would have to be 36, okay? Find the ratios of the lengths of the corresponding sides of triangle ABC to triangle DEF. So we need to check if they're similar, okay? So 2 over 12, which by the way equals 1 over 6, right? So we can cross that out. Does that equal 5 over 30, which equals 1 over 6? So check, right? So we checked, this works out, all right? So now let's do, once again, we can use 2 over 12, which equals 1 over 6, 6 over 36, which also simplifies to 1 over 6, check. So this uses the side postulate, and yes, they are similar, okay? So M, N, and P are midpoints, okay? MP equals 22, all right? MN equals 24, and the perimeter of M and P equals 60. So since that's the case, we do 46. This is 14. I just added these and subtracted from 60, right? Okay. So we're trying to find NP. So we already know what NP is. 14. And YZ. Right? YZ, which is this right here. Alright? So if these are midpoints, this is halfway up here, this is halfway up here, pick up this line. This is half of this, right? So YZ is just 44. Okay? It's pretty easy. All right. How many pages is this? Okay. So find the measure of angle AMN, and the measure of angle ANM. Okay? First of all, we can go ahead and say that these are probably congruent, right? All right, we need to find out if they're similar. All right, this is an isosceles triangle, as is this. And this angle here is the same for both triangles. So this has to be the same as these two right here. Okay, so the triangles are similar. So the measure of AMN and the measure of angle ANM is the same as it is here, 75 degrees. Okay? Now let's look over here. Given that DE is x plus 5 and BC is 3x minus 1, find the value of x. All right? Well, we can go ahead and say, because this is a midpoint and this is a midpoint, this is half of this line, right? So 2x plus 10, I just did 2 times this, equals 3x minus 1. So we end up with 11 equals x. So now plugging that back in, we get 32. So this length here, which is our answer, or not our answer, this length here is 32, and our answer is x equals 11. All right? Once again, we're solving for x, okay? Since this is an isosceles triangle, these two angles are equal to each other, and this is a separate angle. Oops. right? Let me take a look at what I did here. All right. So these two are parallel lines, right? So this and this are alternate interior angles, right? If this was the transversal. So this is 90 minus x. And this and this are also alternate interior angles. So we just set them equal to each other because this is an isosceles triangle, right? So we have 2x equals 90 minus x. 3x equals 90. X equals 30. And that's our answer. All right, let's look over here. We're told this is a right triangle and this is 2x, right? This line here is parallel, we're told, to this line. If this is our transversal and this is 76, this is an alternate interior angle to this right here. So we've got 2x equals 76. Okay? So x equals 38. All right, we know that now. So now, let's pretend this is our transversal, this line here, right? Okay, and so this is y minus 8, right here. Okay? Y minus 8. All right, we know what x is, it's 38. And we know that this here is 76. These are supplementary, right? So 76 plus 40 plus y minus 8 equals 180. Okay? So we end up with 116, 108. So y equals 108 plus, or 180 minus 108, which is 74. Okay? Great. Number 19. Find x and y in the triangle below. Okay? So this is an isosceles triangle. So we can set these two equal to each other. 3x plus 8 equals 5x minus 12. So 20 equals 2x. 10 equals x. So that makes this 15 minus 12, which is 38. So this is, each of these is 38 degrees. So now we can just find that. We do 38 times 2, right? And 180 minus that. So y equals 104. Okay, not too bad. All right, let's do number 20. All right, this is 20, this is 15. So the ratio is 20 over 15, which is 4 over 3 when we simplify. All right, and this, let's call this part y, right? Which equals, let's see, hold on. 42 over y. So we end up with 4y equals, let's see, 42 times 3, 126. Wait. Okay. So we end up with y equals 31.5. So we still need to find x. We just do 42 minus 31.5. So x equals 10.5. Well, I got a completely different answer over here. Oh, I know why. Guys, scratch what I just did. I messed up. Sorry. Even teachers do sometimes. Doi. All right, let me start over, okay? So we have 15 over, this should be 35. All right, I forgot to add them, my bad. So that makes this 3 over 7, right? Which equals, once again, this is y, which equals y over 42. 42 times 3, 126 equals 7y. And that is divided by 18, so y equals 18. And now we just do 42 minus y. So x equals 24. Okay, sorry I messed up there, guys. Happens to the best of us. All right. Let me just erase the board here. All right, solve for y, okay? So, we have 3 sets of parallel lines here, right? So first, I want to, let's see, what did I do here? So we have these 3 parallel lines. If we look at this, oh, okay. What I did was wrong. Oh, I see what I did. Okay, so I do y over 15. So look at this, like this shape. Here, let me draw it in a different color. So we've got this shape. And we've got that shape, all right? So we set up a ratio, y over, let's say 7 equals 15 over 10. All right. We have 15 times 7, which is 105, equals 10y. Y equals 10.5, right? Yep. The answer to 21. And over here, we're already told that these are similar triangles, okay? This is congruent to this. All right, so we have angle, angle, right? So we know they're similar. So now we can do 8 over 12, which equals 2 over 3, right? Equals x, because see, x goes with 8, and 16 goes with 12, equals x over 18. So that becomes 36 equals 3x, x equals 12. Okay, this concludes part 1. Part 2 will be mostly proofs, as you can kind of see, and that will be posted hopefully sometime tomorrow. Okay guys, good luck on what I've shown you so far.